Okay, so hello everybody and welcome to today's event. I'm Jason Gumpert from MSDynamicsWorld.com and I'm really pleased to be able to host this event on sales effectiveness for Dynamics CRM. Our speaker today is Stefano Tempesta. Many of you probably already recognize Stefano's name and maybe have read or heard from him before. He's a newly awarded Microsoft MVP, which was great to hear this month. And Stefano is a returning speaker for us. He's also written some really excellent articles on the use of technology, much like Azure IoT and machine learning for us, and he's becoming quite well known in the community as well. Today's event, we are recording it. We'll also be leaving time for your questions at the end. You can enter questions anytime using the Q&A that you should see to the right of the main presentation area, and feel free to enter those at any point. So without any further delay, I'm going to hand things off to Stefano.
Thanks, Jason, and good afternoon or good morning to everybody. Session today is an experience that I've done a few months ago using Dynamics CRM and connecting to latest technologies provided by the Azure Cloud, the Internet of Things, machine learning, and see how together we can optimize, make sales more effective. The use case really is about optimizing product in stock by looking into patterns and trends of our potential customer and see how these can make our product, our target more effective. So that's really the agenda for today, is going through the different technologies and looking into how we can connect a device to an IoT hub in Azure, and what are the technologies that we need to make this happen, and how we can learn from all the information that is collected by the several devices in the IoT hub and use them to predict demand for specific products. So it's really about tracking our consumer actions. The use case can be as a man, 40 years old, I'm traveling to work. Today is a sunny day because I'm connecting to the weather forecast API. And this is a product, say, that you should consider buying because of all these different conditions. So in doing this, the machine learning application will identify patterns of actions by all consumers. And obviously, you understand that this will require big data in order to identify patterns in our consumer base. And then it can help targeting products according to different conditions. And obviously, the product catalog is in the CRM system. Before we jump into the content, 30 seconds about myself. Stefano Tempesta. I'm based in Switzerland. I'm chapter leader for CRM Saturday for Italy and Switzerland. And as Jason kindly pointed, I've been recently awarded the Microsoft MVP award, and that's me in the NASA Space Shuttle. So here it is. Let's go jump into the content itself. So what are we looking to optimize? Sales. What kind of attributes specifically? We are looking into optimizing three aspects of our sales. Is churn rate, which in sales terminology is basically the percentage of products that our customers drop or dismiss using over a period of time. So obviously we want to reduce that. We want to optimize, so improve the appetency, which is a word that again in sales means interest. It comes from the same root as appetite. So I want to understand the appetite of customers for specific products. And then obviously we want to do a bit of upselling. So customers that have bought this product can also buy this and that. All these three properties make our sales more effective. And the way we can optimize our catalog in the CRM and target product to specific audience is by, on one side, collecting as much information about our customers and understand what are their preferences on adopting, on buying, on specific products under a number of conditions. And then machine learning will read into this data set, identify patterns, and then provide a likelihood, a prediction of demand of a specific product. We are looking into 5 attributes. In machine learning, they're called features. We're looking into age, into gender, male and female. We're looking into skin type, and the reason of skin type is because this use case specifically is for active cosmetic company, so they provide creams, and then obviously the type of the skin has an influence on the type of cream that or cosmetic that you may want to apply. Location and season, winter, summertime, obviously different creams, sun protection, or any other different product that can be applied depending on the weather conditions. So let's start from the Internet of Things offering by Microsoft. Specifically, the Azure platform comes with a number of components that can be used for collecting data from different devices and then provide a data set for the machine learning. The IoT suite is one bundle of all different components that are prepackaged and ready for interfacing, for connecting wearable devices or mobile apps and stream data continuously to the hub. So that can be data about weather conditions, can be data about location or tracking, can be data about UV exposure, or can be profiling the user according to other conditions, as we said, weather, season, location, gender, and so on. So what is the IoT suite? And you can see it is available at azureiotsuite.com. It is a collection of services, all provided by Azure, that help us to build 2 kinds of solutions. Predictive maintenance is a type of solution that we can build for anticipating needs for maintenance of devices, and remote monitoring is a type of solution that we can build for real-time tracking, streaming of data to the hub. This is the solution that we need and we want to use, the remote monitoring. I will jump into showing this into the azureiotsuite.com website in a second, and then we'll keep on talking about the IoT Hub and how that represents the heart of the entire suite, the point of collection of all data from all the devices and storage of information into a central repository. So let me just get off the slide deck for a second and move into my browser. As you can see here, let me zoom in a bit so you can see this better. I'm in the azureiotsuite.com website. It is free for everybody to register, and then you can create solutions here. So let's pretend we are creating a new solution. You will see there are 2 solutions types: the predictive maintenance to anticipate maintenance needs, and the remote monitoring so that we can connect our devices and start streaming data in real time. I'm not going to create one now because it takes around 15 minutes to spin one off, but if I were to, you will see that obviously after giving a solution name, picking a subscription, we have to pay for these services, right? And then a region where we want the solution to be hosted. Then the solution will create a good number of services in Azure. It will create an Active Directory where all our devices are classified, the hub, and I'll come back to the hub in a moment, DocumentDB, a NoSQL repository for all the data that devices stream to the application, and a lot of other things, including a big map, including a Power BI, including a few other services that are used to display information on the screen. So I'll go back and actually launch the existing one that I've created before this webcast. And as said, it takes around 15 minutes to spin off all these services. Right, I need to sign in, and here it is. And all you need is a Microsoft account, really. So let me just zoom out a second so that is better to see. And as you can see, there are a few components here on the screen. And this is really a dashboard that is prepackaged, zero coding, zero development time, is all provided as part of the IoT suite. It shows a big map. All the pins that you see here are the locations of the devices. Now, as you create a new IoT suite solution, you get some simulated devices. So we don't have real physical IoT devices connected. We have a simulation of devices streaming data to the IoT suite, specifically to the hub. And you can see a list of all the devices here. We have 1, 2, 3, 4, and 5 simulated devices. They are streaming data about temperature and humidity. The two lines that you see on the screen, they are in real time collecting information from the devices. We have a history of all the actions, of all the rules, to be more specific, that are triggered when a device sends a signal to the hub. And we have a few other gauges provided by Power BI to show the average humidity, the maximum and minimum of information that has been collected. So the devices, and here we get into the configuration part, the back end of the IoT suite, as said, are simulated in this case, but we can easily add a new device as a simulated one again, or a custom device, a physical hardware device. That can be your Fitbit, or it can be any sensor that run and can connect on to the Azure IoT Hub using RESTful API and endpoint. We'll get into that in a moment. So if I were to create a custom device, I will need a device ID that I generate, and here I can type my ID and register the device. But I want to show you how to register the device programmatically, because by doing this through the UI, I'm registering an ID, but not attaching the device itself. If I were running an application, a device running on, say, Windows IoT Core, I will be able programmatically to register the device to the suite. And this is what we have done in our solution. We have developed a little app that you can install on the different devices, and then the app will connect to the hub by sending a unique ID. So let me get back to the slides for a second and complete the presentation of the IoT platform. The hub, as said, is the core, is really the heart of all the functionality of the suite. It provides two main things: a registry of all the devices in the Active Directory, and a bidirectional communication, a secure communication. The registry is necessary for authorizing devices to communicate with the hub. If you are registered with the hub, you can initiate a communication. Otherwise, you are not. Obviously, this will provide kind of a secure channel. The hub exposes HTTP endpoint or other protocols, but mainly an HTTP endpoint. So we don't want to overuse the hub with the devices that are not authorized. And then once the device is registered, we can establish a communication. Each device is identified by a unique ID, and the communication is bidirectional from the device, streaming data recorded by the sensor for, again, humidity, wind speed, temperature, location, anything that the sensor in the device can collect, and then send this to the hub, and the hub store this information into a document DB. But also the other way around, the hub can talk to the device, and this typically happens for devices that go into standby mode, devices that require battery to run, and therefore to enter into a battery saving mode, they shut down operations, they go into low consumption during collection time. So say that they stream data every minute or every hour. So in between the collection point, they just power down. The hub will send a signal, an awake signal, to say, hey, wake up, I need some information again. And the device will be triggered to send the information. Or other application where the hub talks to the device if we want to wipe data remotely, or if we want to disconnect a device that is not functioning. So the hub has a full control on the device. And there are different levels of policies or permissions that we can set up in the hub to have control on the device remotely. So I want to show also the hub in Azure, because everything that we have seen here in the Azure IoT suite is prepackaged, but these are all individual components that you can create separately, one by one, from the Azure portal. You wouldn't do it because it would take a lot of time, probably. The IoT suite will do that automatically for you, but you have full control on all and each of these items, of these services in Azure. So let me switch to my Azure dashboard, and if I have a list of all the resources, you will see there are a few resources that start with MSDW, and they are all storage account, event hub, app service, IoT hub. Let me zoom in a bit again so it's better visible on the screen. A NoSQL document DB, app service, stream analytics job, and so on. So they are all services provided by Azure specific to the solution that we have built in the IoT suite. So the IoT Hub, as said, is the core of it, and there are a couple of elements that are important to understand from this IoT Hub. One is the host name. We need a host name for enabling communication from the device to the hub. And then we have, and here you can see there are information about the message that have been exchanged, the number of devices that are currently connected, and then we have the policies. The policies are think about an account, a login for authenticating and authorizing messages. The IoT Hub owner is obviously the one with the most of the permissions. He can read and write into the registry, and he can connect services and devices. And then we have service, device, registry read, registry read and write that are more specific. The IoT Hub owner, as said, is the one that has full access, and you have a collection of keys and connection strings for programmatically connect to the hub itself. And the last things I want to show you also in the hub is the list of devices. We have the 5 devices, simulated devices, that were auto-provisioned by the IoT suite. And then there is a test device that I just created before this webinar, just to double check that everything works fine. You never know. All right, so how do I register a device? Okay, the technology that I'm going to use is Windows IoT Core, using the .NET framework, C# as a programming language, to register a device and with a hub, and authorizing the device to stream data. So I'm going to switch now to a project in Visual Studio, this one here, and I'm going to create a new device. That was my test device before. Let's call it MSDW device 001. Now this can be anything. Can be a GUID, can be any made up ID. It is a string. It is unique to each device. In order to connect your device, or actually to create this program for connecting the device to the hub, you need to reference a package from NuGet, which is, let me zoom in again a bit, the Microsoft.Azure.devices package is an SDK for the Azure IoT devices. So once you get there, you can reference in your project, you have a device registry, and then you register your device and you send the information about the device ID to the hub. You get back a primary key that then you need later for enabling communication. So this is only the registration. After you've been registered and authorized, then you can start talking to the hub, and also a message whether the registration was successful or not. The parameters for connecting to the hub are in your configuration file. So is a connection string that contains the host name as in the Azure portal, my policy, in this case I'm using the IoT Hub owner, and my access key. So that's my connection string. That's all I need. And if I run this application, so let me actually run it as msdw-device-001. This is simply a console application, no specific UI, nothing fancy, but it just registered the device. And let me zoom in a bit so we see the result. Here we go. Device, register with key, and this is the primary key that I need for connecting the device to the hub and establishing a communication. So now, if I were to kill this and say I'm running again with the same ID, okay, so I'm not changing the ID, I'm running this again, you will see, you will get an exception that the device is already registered. And that is actually proving that there is only one device with a unique ID in the hub. Now, if I go back to my device list and refresh, hopefully it gets there. And here it is, my device that has been registered with the IoT Hub. Right, I didn't copy the key from the console, but fair enough, I can copy from here. So I'm copying my primary key that will help me to connect to the IoT Hub. So I switch back to my solution, and I've created another program that simulates streaming of data from the device into the hub. Now, obviously, if I were running a physical device here, this will be the real data collected by the sensor of the device going into the hub. I'm running everything from my own laptop, so the best thing I can do is to simulate this communication. All I need to do is the same host name as before. the ID of the device, which was MSDW, and then the primary key that I've just copied. Here it is. Done. And then I can run the device simulation. So what this device simulation is doing is basically creating an instance of the device client from the connection string. The device client is our wrapper for sending messages from the device to the hub asynchronously. So we send the message. In this case, I'm generating a random number of pretending to be a UV exposure, collecting the data point as a device ID and UV exposure, serializing a JSON, and sending asynchronously to the device. And then I'll do this every 3 seconds. I'll wait for 3 seconds before carry on with the next collection point. So if I run this, if I go here and run this specific simulated device, let me zoom in a bit so you can see, the device will start streaming data every 3 seconds, simulating some UV exposure. Hopefully it will stop soon. Here we go. So at 38 seconds, at 41 seconds, is sending the ID of the device and some random number of UV exposure that have been generated. So put this in the real context, with a real physical device. This is all you need to do. Send a JSON message to the hub having your telemetry point, your device ID, and all the attributes, all the properties that you want to stream. This will be collected by the hub and stored in document.db. All right, I'm going to stop this now and get back to our slide deck. Sorry, let me just double check that, yes, the device is still there. Here we go. So, in a nutshell, just to recap, that was the first part of the solution, the implementation. We have the physical devices that are owned by customers, a mobile phone, a Fitbit, anything that is connected to the internet and can send data, and this is used to collect as much information as possible using the Azure IoT platform. Now the next step is, after we have collected all this information, analyzing it, making sense of it, identifying patterns, and provide recommendation and provide an estimation of demand for products that fit, that are suitable for the different types of customers that we have identified. And the way we do that is using the power of machine learning. So, machine learning. First of all, there are different implementations of machine learning. It's not a Microsoft thing, obviously, but there is a very good implementation of machine learning in Azure, available at azureml.net. What you get there is a machine learning studio, which is a web-based, so it runs in the browser environment for developing experiments of machine learning. It starts with defining a data set, so the information that you need to gather, and you can run different types of experiments. Sentiment analysis is a typical application of analysis of text in, say, social networks to understand the happiness or sadness of customers towards your brand or products. Demand estimation is the one that we're going to build now today, which is an algorithm, an experiment for predicting the demand of a specific product given initial conditions. Outcome prediction is along the same line, with the difference that it works on predicting an outcome of likelihood that something is right or wrong, based again on different features, different variables, is broadly used, for example, in credit risk assessment or in online payment fraud analysis, where you have an undefined data set, and then you have to predict the outcome based on a number of conditions that the machine learning experiment will analyze. And then we have the other one, the fourth one, recommendation, which is the Amazon model. People that bought this product, they also bought this and that, so used for a bit of upselling. Now, the beauty of the Azure Machine Learning is that everything that we analyze and generate as part of the experiment is available as a web service, specifically as a RESTful API. This is fantastic because you don't just run the machine learning on its own. You can actually connect third-party application to machine learning. Is machine learning as a service, is demand estimation as a service, is outcome prediction as a service. And this is the connection point to our CRM. Our CRM, using a flow to connect to the web service of machine learning, is able to send data in input and then receive a demand estimation as a likelihood in output, and then internally adjust, in this case study, product stock availability depending on the demand estimation. We'll have a look into that at the end of the analysis. So the machine learning process is really about identifying the initial data set, and we have done this as part of our IoT collection of information. The more the data, the better is the analysis, because obviously if you want to run a pattern identification, you will need millions of records to try to identify trends of different customer types. Then we run the experiment and we do the demand estimation, and then we have identified a trained model. So the process of creating an outcome out of an experiment is to train the model, which is basically I look into the existing data and understand what happened in the past, understand and identify patterns. Then I need to score the model, and the scoring process is a prediction of what happens if some conditions are identified in the future or under different contexts. So for example, I train the model that these patterns of consumer actions exist in my data set. What happens if I do this, this and that? What happens instead of summer is winter? What happens instead of a male 40 years old is a woman 60 years old? What is the demand estimation by changing variables? That is the scoring part of it. Last but not the least, we need to do an evaluation of the model. And this is important as a quality insurance. So the evaluation is actually a QA of the experiment. It defines that the data that is generated as part of the scoring consider all the aspects, all the features of the data set, and not just a few of them. So I said as an example, what happens if 40 years old male has unidentified patterns, we change the variable to a 60 years old woman. So we need to make sure that the classification is consistent with the patterns that have been identified. If the 60 years old woman is not in our original data set, the prediction obviously will be less accurate. Then we also make sure that there is no regression in the scoring, in the prediction. So if the 40 years old during summertime and in that specific location was faithful to a product, my scoring cannot introduce a different outcome. It has to be consistent. So I want to make sure that there is no regression during the scoring. And then the last element, that the evaluation, so that my QA process does, is looking for clustering of data, so that the scoring is evenly distributed among all the features, and not just clustering around age or around weather conditions or around skin type and so on, but we have an even distribution of estimation according all the different variables. It's really a QA process. So the outcome at the end, as said, is a RESTful API. So this is the Azure Machine Learning Studio. You have on the left-hand side a panel with a lot of different items that you can use as part of the experiment, from dataset to data transformation, machine learning algorithm, statistical functions, the web service itself. And then in the central area, you define your flow of actions as said before, from dataset to training, scoring, evaluation, and then the definition of the web service input and output before we can use it in our CRM application. All right, I'm sure you want to see this in action, so why don't we get off the slides and into my machine learning. Zoom in a bit, and you can see we are in studio.azureml.net. This is my Azure Machine Learning Studio, completely online, completely in the browser. So what you can do is really defining projects. And a project is a collection of experiments, web services, datasets, and so on. Now, speaking of datasets, there are a couple of ways of importing your data into the Machine Learning Studio. So let me switch to datasets here, and there are a few that have already been imported. One is as simple as uploading a CSV file, and you have your CSV generated offline, and then you upload it into Machine Learning Studio. Or you can use a notebook in R or Python. And if you are familiar with R, you will probably be able to understand what is in this notebook, which is basically loading the dataset into the workspace using the Azure Machine Learning library. And another way of getting access to this data, again, in Python or in R programmatically, is to have an authentication key that, and sorry, here it's been highlighted in the wrong way. Here we go. An authentication key and an endpoint where you can upload the data sets, again, programmatically. So by doing this, using a web service, using and connecting to Logic Apps, a Flow, or any workflow tool, we can extract information from the IoT Hub and programmatically, regularly, upload the dataset into our machine learning. So we have the dataset that I've uploaded previously, weather data in this case. I want to build a new experiment of predicting demand of a product on the information that I've collected before. So here I am. I create a new experiment, and as you see on screen, there are a number of templates that I can use for credit risk prediction, breast cancer detection, customer relationship prediction, direct marketing, flight delay prediction, and so on. So they're all around the 4 different solutions or experiments that we can build: sentiment analysis, demand estimation, outcome prediction, and recommendation. There are different flavors that obviously you can adapt to your business model. Now, we create a blank experiment, and we start from the ground up to define our demand estimation experiment. So I can call it demand estimation or product demand estimation. Okay, let me call it product demand estimation. Here we go. All right, we start from the data set. Okay, so my data set is my weather data, drag and drop in here, and here it is. I have my data set well defined. How that looks like, actually, I didn't show it to you. Let me visualize the data set. This is a simple one, contains different devices, different age, gender, skin type, the date of collection, the weather, it was rainy, it was cloudy, it was sunny, the temperature of collection, and the product that was recommended using for these conditions as identified. Now, we want to train our experiment on this data set. But before we do that, there is a process of the training that is called data split. Now, it is important to separate, so I'll do this as a data transformation, split data. It is an important process because I need, oops, you can see here I can do drag and drop and connect the two. I need to define a percentage, a fraction of the rows in my dataset that I use for the training, and the remaining part that is used for the scoring. And as you see, by default, the recommended value is 0.5, so 50% will be the data set that is used for the training of the model, and the remaining 50% for the scoring. The number actually that you want to define here is a direct relation with the accuracy of your information. I am not playing too much now with transformation or data format conversion, but what you can do is actually clean up data, do a bit of data cleansing, or manipulating data, transforming format, or you can add values where values is not existing. It really depends on the quality of your input data. If you have, or if you are uncomfortable or not extremely convinced in some way that your data and input is of extreme quality, you want to do some transformation and some conversion of your input data. But if the accuracy of your data set is good enough, so you don't have missing values, you don't have incorrect format, then you can confidently increase the fraction of rows that you want to use for the training. So the training, the important rule is the training has to be on the highest quality possible of your data. Otherwise, you're learning on something that is not accurate enough, and obviously the prediction will be wrong or not accurate enough. Now, my data set, I'm confident enough as a good accuracy, so I can easily increase to 80% and 90%. So let me go for 80% here. All right, so I have a split. Now I need to start the training. That goes under the machine learning. So let me close this, go under machine learning and train. I drag and drop. So you see, even if you're not a data scientist, you can relatively easy easily build an experiment in machine learning, connect these two, and then define how you want to do the training. So this is your item for executing, is your action for executing the training, but the way you define the training algorithm itself, that probably is where the data scientist will help you, because it will define the best approach to take to training. And there are hundreds of different ways of doing training based on the quality of data, as we said, based on the relationship of data with other variables. It will take probably another full hour to go through all the different algorithms that exist as detection of anomaly, classification, clustering, regression, and so on. Unfortunately, we don't have the time. I would love to be honest, speaking about boosted decision trees, speaking about neural network regression. What we're going to use now is a linear regression. Linear regression is probably one of the most used, also because it's one of the most performing algorithms for doing regression analysis. And regression analysis, to be honest, is more of a statistical function. It doesn't relate strictly to machine learning. What it does is basically saying, and let me connect this here, is let me identify a correlation between one variable and the other one in input. So the one in output that we want to estimate the demand, our product, and the ones in input that we provide. Now, it is called linear because we expect a linear connection between the input data and the output. So it works well if we already know what is the correlation between data. For example, if it is cold temperature, I expect to put this product. If it is warmer temperature, summertime, I expect to put this other product. So there is a linear correlation because it's very unlikely that the situation will change. This is a product for low temperature, this is a product for a higher temperature. So the correlation is linear. Now, I said product, so we have to define what is the variable that we are going to use for our demand estimation. So I select this into the column that I want to select to predict, so is our product, and save. So I'm ready for the training. The next step is the scoring. So I'll add scoring here, and as said, scoring is a combination of training and the remaining data that we have split before. And last but not least, our QA process, our evaluation. Our evaluation is basically telling the score model to look for regression, to look for classification, and to look for clustering as conditions for scoring the model with accuracy, for scoring, so for predicting our demand. So let me save this now and run. You will see there is a little tick on each item that will be enabled and will show. That was super quick actually. It's already finished running. That will say when each of the item in the experiment is complete. Sometimes take a few seconds. That was really super quick, excellent. If we were now to look into my score dataset, so let me visualize this on screen, you will see that besides all the features that were in the original dataset, we have a new one, score label. This is my demand estimation for the specific product against every single feature that we have identified in the data set. And to see that this is a linear regression, I can compare, say, to temperature, because this is actually a collection of weather data. And you will see, let me zoom in a bit so it's clearer, there is a kind of linear correlation between higher temperature and the demand of a specific product over time. So this is the linear regression that we have identified. Now, how that works from a CRM perspective? Well, I need a web service. I need to be able to define this information in output. So I'm going to create a web service here. That should take also a few seconds. You see the magic is happening, all the boxes are moving. Web service done. I'll save it. The input, let me call it input data. So that's the name of the variable that contains the information in input. And this is the output. And then I run the predictive experiment that generates a web service. And when this is done, what I obtain is a web service. Few seconds and it will be done, hopefully. So the web service, I said, is a REST API. We have a URL that we can use, and from our solution, from our CRM, connect to this URL, get the information, and then display, and then trigger any action in the CRM according to the information that we receive. This web service is taking a bit longer than what I expected, but hopefully will be done soon. So then all the process end-to-end basically is it all, finish running. So I'll get back into that. So let's deploy now this web service, and the deployment is providing the experiment as a service. So it is deployed in Azure Machine Learning. It is hosted in Azure Machine Learning. It's hosted as a REST API. So I'm opening the tab now, and then you can see there is a URI, which is the endpoint that you need to use. So let me copy this. It is a post. So this is my REST verb that I have to use. In input data, you need to provide some values for each of the columns that we have defined. And as a response, in output, you obtain the score labels. So if we were to do this in code, this is what we need to do. I have an application here that calls the web service using my, let me see, my client API, posting as a JSON message and displaying in output the variable. Is sending some random values for device, age, gender, skin type, and so on. And then I want to get as an output the demand estimation for the specific product. So I need to change the endpoint that was from a previous one, because it obviously is different from service to service. And I need also to change the no, where is it? Here it is. The API key, because again, the API key is also unique to each web service. And then if I run this is a console application for the sake of showing the connection to the web service from a C# code. It will hopefully run very quickly and display the result on screen. So let me zoom in a bit. And it is. So this is my JSON input, and this is my demand estimation 1092.5 and so on. Based on this value, I can go into Dynamics CRM and or in any system, but obviously in our catalog of product is in CRM, and adjust the product stock accordingly based on this demand. Now we are running a bit short of time, so I won't be able to show you also how to run this in Excel, but if you have followed me so far, to do it on your own, you will see that you have also the possibility to download an Excel spreadsheet. This is a fantastic thing for testing manually the web service. You download an Excel spreadsheet. Excel will connect to machine learning, to the experiment in machine learning, using an add-in for machine learning itself, and run your experiment with sample data that you can define in Excel. It's a way to test your machine learning experiment manually from Excel before integrating with CRM or any other application. All right, so conclusions. Machine learning helps to make sense of the hundreds of thousands, millions of records that we collect in the IoT suite. Identify trends, and based on the trends, make recommendation, make the estimation of demand of a specific product. This all in all goes into a CRM, into a product catalog, and based on the demand estimation, obviously stock can be adjusted according to season, according to target audience, according to location, and so on. This is the case study. Before we open for a few questions, just a few pointers. One is, yes, we have done a bit of analysis here to understand how the demands change. Actually, you know what? I want to show you this in Power BI because it makes more sense. Here it is, because it's a live thing. So this is the real data, and you see applied by age, 20, 30, 40 years old, and this orange line is the demand estimation for a specific product. So in people in their 20s, the demand drops in this way. People in their 40, different demand. People in their 60, and so on. I can drill down and differentiate between female and male, and you see the lines are completely different because the products for female and male are obviously different. And I can do the same also by weather, cloudy, rainy, or sunny, and the product line change, or I can drill down between even afternoon and morning because, for example, the exposure to UV rays is different between morning and afternoons. So this is all the information about the product, how they are acquired, they're consumed, and they will provide inputs to the CRM for doing stock allocation. All right, that was very briefly, just to have an idea of how this information is actually used, to get some insight about it. Let me close with a few pointers. As said, I'm on the board of CRM Saturday, so have a look. CRMSaturday.com is going around the world. We had last week an event in Dublin. We're going to Zurich. They are coming to Zurich, actually, to my home in May, and we're going around the world, touching Melbourne in Australia, Dubai, Milan in Italy in the next month. So if you want to be part of it, it's a free event, completely no profit, a full day on a Saturday. I'll be doing this session again at the Summit EMEA from the CRM UG. So if you happen to be in Amsterdam in April, come along. We'll be more than happy to talk to you directly about this experience. And obviously, as Jason mentioned at the beginning, there is an article that I wrote for MSDW about this experience. So come along, have a look, read it. It's been a bit of a run in this hour. There is a lot to talk. I would love to talk a bit more about the IoT and the machine learning, but we're getting in touch, and I will be happy to answer your questions. So that's my pointers. Questions. Jason, do you have any questions that you have collected from the audience so far?
Yeah, so we have a few questions that have already come in. Please do enter yours at this point. I know we're right near the top of the hour here. So I'm just scrolling through them here. So I have recorded today's event. Several people have asked. We're going to be sending an email out to everyone when that's available. So someone asked about details on sensors. In your example, there's the device type, skin tone, weather data was collected together. Can you give any other information on how that, on sort of how you compiled that data?
Yeah. So different devices have different sensors. Not one device can collect all the kind of information. Well, to be honest, if you ever played with a Microsoft Band, that is a very nice wearable device that collects a lot of information about temperature, skin type, UV exposure, location, and so on. But typically, other devices are more specific to the few sensors that they have. So there are devices for temperature, there are devices for humidity, devices for UV exposure, and so on. Yes, so the device itself needs to be programmed in a way that it can connect to the IoT Hub and stream data using the endpoint to define the IoT Hub and sending JSON messages. If you are running on Windows IoT Core, the programmability comes with .NET, so you can use Visual Studio. Any other device in any other programming languages, as long as they are able to talk HTTP JSON to a remote endpoint, are absolutely fine. The IoT Hub is not for .NET only, it's for any programming language, for any device that is able to send a JSON message over the wire.
Okay, and I think the other, if I was going to summarize a couple of the other questions here, it's asking, will you do a deeper dive, or can you, in the future, provide a perspective on this that dives deeper into usage with CRM screens directly? So that might be something for the future. And by the way, thank you for that feedback. And as you leave today, also look for the survey that pops up. That's another great place to leave additional feedback if you want to write more as we end today. So that is, I'm just looking here to see if there's anything else. No, so I think that's the end of the questions, and I know we're at the top of the hour here. Stefano, anything else you wanted to close with?
No, that's it. Just want to say, if anybody is techie and interested to source code of the solution, feel free to reach me. It is attached to the article anyway. So have a play and happy coding.
Yeah, and I did post a link to that most recent article as well in the chat if anyone is looking for it. Well, Stefano, thank you so much for taking the time to run us through this fascinating set of capabilities. I really appreciate you doing it.
Thank you, Jason. Thanks for the opportunity, and bye, everybody.
Yeah, bye. Thank you, everyone. That concludes today's event. Have a great day.